have our mathematics coach, Kim Porter, here to speak about maths at UWC in the primary school. Hi Kim, thank you for joining me today.
Hi Pauline, good to see you.
So I think you're going to talk generally about maths, but about a particular strategy we use in the primary school as well. Over to you.
Yeah, so we use what we call build, draw, write, explain. It's a mathematical process based on a lot of mathematical research around how children learn mathematics. It's from the approach, the CPA approach, or concrete, pictorial, abstract, that we know that first children have to be concrete with mathematics. So they have to be able to manipulate it, move it, build it. So we start with building using math tools, and we want children to learn to be strategic on what tools they're using in a particular problem.
Oh, I see.
So they're not just using any tool, that their strategy and different math tools help us with different things. Then we move to the pictorial. So once they really have good conceptual understanding with the tools, then we move to them modeling that mathematically through a drawing. And then that enables them to go to the abstract, which is what all of us adults were taught, those numbers and symbols and what they actually mean. So we never want to jump kids to how we were taught.
Yeah. Now, that's really interesting because we did have a parent curriculum workshop earlier in the year where parents had a chance to actually use this strategy. What did we notice then?
Yeah, it's really difficult for parents because all of us adults, were just taught procedures. We were just taught to follow step 1, step 2. We line up the ones, we add them up, we move to the tens. But that's actually not conceptual understanding. So really it's the difference between becoming really good at arithmetic and being human calculators versus being mathematicians. And so for the parents who attended those workshops, it was really these aha moments. I remember one parent said, "This is way better than how we were taught in my country." And it is because it's building such deeper understanding rather than just following a process. Because I know for me as a student, just following that process, I got to a certain point in mathematics in high school where I didn't actually understand it and couldn't do it because I didn't have conceptual understanding. I just could follow a procedure.
And I know it's actually quite hard to go backwards, isn't it? So for some of those parents, they were really struggling with how to actually draw. They could come up with the answer, but they couldn't draw and then represent it pictorially.
Yes, and we always end with explain because you have to be able to explain and justify your thinking. So for those parents who have, can you tell me the answer? I'll say, okay, what makes you say that? And it's really hard for them to justify what their thinking is, or they'll just, often parents will tell me, well, I was just taught that way. So that's really clear that there's not conceptual understanding there, and we do not want our children to be in the same situation as us. We really want them to be mathematicians.
And it's a huge improvement, isn't it, that we have that approach now, because actually getting children to explain, for me, is one of the key parts of that. And they learn from each other that actually there's more ways than one to get to the answer. Whereas when I was at school, and I actually was quite good at maths, but it was very, very learning things by rote, regurgitating it, and as long as the answer at the end was right, nobody was interested. Nobody was interested in anything else. So it's called
Build, Draw, Write, and Explain. And the build is the concrete part. The draw is the pictorial. The write is not writing words, it's writing those numbers and symbols. That's the abstract that you and I were taught, and all the adults listening. And then the explain is that further justification that none of us ever had to do.
Okay. So that's the process and the strategy. What does it look like for children? What would we see if we walked into the classrooms here and the children were using this strategy?
Yeah, so in the build phase, you see it's usually applied mostly to problem solving. So even if students are doing what I call naked numbers, they're numbers not attached to real life, they're just on their own. The calculations
I love that term, naked numbers.
Naked numbers. The calculations you and I grew up doing. You may see a child building that with tools, learning how to understand just that calculation. And then as they go through a process, really the building and drawing helps them when they're applying it into real life. So when they're looking at a problem-solving problem, getting those tools, drawing that model is actually helping them solve the problem not just doing the algorithm or the process that you and I were taught. So you'll see tools spread out. You'll see kids using different tools. You'll see them try one and maybe that didn't work the way they want, so they have to rethink what tool might be better in this situation. You will see kids talking a lot because they have to explain, they have to justify their thinking. We learn much better together than we do apart. COVID taught us that for sure. Reiterated all that research that was done prior to COVID. And so you'll hear them talking and explaining their strategies because they do better learning from each other and trying things from each other. Those would be the key things that maybe would be different than the classroom that we grew up in.
And it's interesting because it's not just the explaining to each other, it's actually vocalizing it as well. I know myself, if I say things out loud, I'm more likely to remember them. The same with drawing or writing, I'm actually more likely to remember things. So it's a great advancement. And even some standardized assessments, dare I ask, actually do recognize that explanation and planning it out, not just the answer, which is a great step forward, I think.
Yeah, it is shifting slowly but it's shifting.
And so my final question is always about parents. We mentioned parents coming in and trying, but that was a small number of parents. So for all our parents, what should they be noticing?
Ask your child and notice what their thinking is, not just what their answer is. So ask them, what makes you say that? Or how did you solve that? Ask them to explain, really get into the explaining part. Because if they're just telling you the answer, or if they're just following the process that you and I were taught, or that they're often taught in tuition classes, then they're really not necessarily showing conceptual understanding. They're just calculating what their phone and calculator can do now. So really noticing what's their strategy, what's their brain doing. So often I just ask the kids, that sometimes they have a hard time at first. The kids will be like, well, I just knew it. Well, tell me what your brain did. Yeah. How'd your brain get from these numbers on the paper to what you're telling me now? And often I'll coach kids, okay, what did your brain do first? What did it do next? And getting kids to explain their thinking. So as parents,
step by step,
ask them what their brain is doing and how they figured it out, not what the answer is. The answer is, sometimes I say we all know the answer is 25. Yeah. How'd you get it?
And the interesting thing is that deepening that conceptual understanding then means, as we know, they can transfer it to real life situations, because that's something parents could do as well, be asking those questions as they're out in the real world.
Definitely. When you're out and about, kids will notice maths just as you're walking about or in the car or wherever you're traveling on holiday. What maths are we noticing? And I recently was stuck in the Copenhagen airport, and there were so many people, but I just snapped a photo and I put it online. What's the maths you see? And what came out of it was people were talking about multiplication of the lights, making an array, all these different things. And the kids will do the same thing. What's the maths you notice?
Yeah. And they're becoming more eloquent and more articulate at explaining that, which is all down to
build, draw, write, explain.
Thank you so much. It's been lovely having you today. Tune in next time for Patter with Pauline.